Okay, let's see how we can check our work using TinkerCad. First thing you need to do is start up TinkerCad. Get yourself a small breadboard and then start placing the components that we need. We need a resistor. Hit the R to rotate it. And then let's just go ahead and place it here. And this is 220 ohms. This is the first resistor. We need another resistor, and we can go ahead and place it here. This resistor is 470 ohms. And then our final resistor, rotate it, oops, and we can go ahead and place it here. Now remember, this is a series circuit, so 1.2 k ohms is the value for this final resistor. Now this is a series circuit, so we should have our current coming in here, flowing through the resistor, out through this resistor, and back to the power supply. So let's go ahead and switch this to all. Let's find our power supply. All right, we need a power supply. And let's go ahead and set our voltage now, 12 volts. Then we're going to need a bunch of meters. We'll use this one to measure the voltage drop on this resistor. We'll use this one to measure the voltage drop on this resistor. And we'll place one here to measure the voltage drop on this resistor. Now, let's go ahead and start making our connections. Down about there and there. Now this is our ground wire, so that should be black. Now let's take our power. It should be around there. This should be red. And straighten that up a little bit. Now let's finish making our connections. We'll go from here to here. And it really doesn't matter what color you make that. We can leave that as black. And then from here to here. And we'll just go ahead and leave that as red. There. So now we have a complete circuit that flows through here, through the resistor, and back to the power supply. We turn it on. Notice we have 12 volts. And the power supply says we're drawing 6.35 milliamps. That already tells you the current through the entire circuit. Now we need to know what the voltage drop is for this resistor, this one, and this one. Let's go ahead and stop our simulation. And let's wire. It's red. The red lead on our meter. And black lead on our meter. Now let's see what the voltage drop is across this resistor. Hit start. And we have 1.4 volts of the 12 is being dissipated right here. Now we want to know voltage drop here and here. So stop the simulation. Connect the negative lead there. Positive lead across that one. Here, let's make this red. Make that black. Start our simulation again. We now have 1.4 volts being dropped here, 2.98 being dropped here across this resistor. Now we just need this last one. So let's go ahead and hook that one up. Now notice this is the positive lead on the voltmeter, so we want to connect it to the positive side of the resistor, which is right there. We'll make this red. Then the negative side of the resistor. There. On black. And you know, if you want, we can straighten our wiring out a little bit and make it neater. Same thing here. Notice at that angle, doesn't look very good. Double click on the wire to add a node to allow us to straighten these out. And there we go. And we can do the same thing with this one. There we go. All right. Now if we start our simulation, we have 1.4 volts being dropped here, 2.98 being dropped here, and 7.62 being dropped at this resistor. If we total our 3 voltage drops, they should equal 12 volts. Our current through the entire circuit is 6.35 amps. Now let's stop the simulation, and that's one way you can check your answers. Alright. Okay, now let's look at the parallel circuit example. In this example, we want to know the current that is flowing through R1, R2, and R3. And the way we're going to do that is by dividing our voltage by the resistance. So it'd be 15 volts divided by 470 ohms. It'd be 15 volts divided by 2,200 ohms. Be 15 volts divided by 3,300 ohms to get us the different currents. So let's go take a look. Now, one of the things that you'll notice with the meter, whenever you're trying to measure current, the meter actually becomes part of the circuit. So the electricity flows through the resistor, through the meter, back to the power supply. So we have to have a complete circuit all the way through. Let's go ahead and turn it on. Okay, I did something on purpose just to show you. Notice how it says 15 volts here, 15 volts, 15 volts, 15 volts. Right now the meters are connected correctly, but they're set to the wrong setting. Notice how V is what's highlighted. That's the default setting for the resistors. For the meters. If we had done this with the real meter, we would have blown a fuse in the meter. So let's go ahead and set them to let me stop this. Move this there. And we have our results. We now know that the current flowing through resistor number 1 is 31.9 milliamps. Through resistor 2 is 6.82 milliamps. And our last resistor is 4.5 milliamps. Now we also wanted to know total current. And we can look at the power supply, and it tells us that this whole circuit is drawing 43.3 milliamps. Let's refer back to our PowerPoint and see if that's correct. Pretty close. The differences are very minor. So there you have it. Easy way to check your work.